I acknowledge Gujarat University and other delegates concerned for the honor to be a part of this FDP and some of the experience of my career I'll be sharing. I mentored two centers. One center is the Center of Excellence for Geothermal Energy, which is a multidisciplinary center recognized by Government of Gujarat, Government of India and Ministry of New and Renewable Energy. This center has evaluated several subsurface geothermal hotspots, which is first of its kind, using various survey technique and has drilled 6 wells till date in Gujarat. It also found out the hottest well in Unai with a surface temperature of 70 degrees Celsius. People concerned has understood that exploitation of the geothermal energy is necessary using the drilling technology, the deep drilling technologies, and also using the energy harvested into meaningful energy which can be fed to the grid. As a demonstrative project in Dholera, we have showcased that the energy which is harvested can be fed to an organic Rankine cycle which has produced an energy worth of 50 kilowatt which is fed back to the system. An example to describe how this concept is utilized for seismic sections and drilled wells which will be integrated in order to understand the play and lead phase, how it goes into prospect phase, how it goes to a drillable prospect phase, and how we can convert a contingent resource into reserve. Now at the lowest level you can see here that the play and lead is understood based on seismic section, based on the lease which has been given to you maybe by DGH to work upon. You can see here that there is a migrated section which is shown on the right. The southwest and northeast of the section is shown, but it is not interpreted. With naked eyes we can see a long fault and a large fault which is there, which divides the section into two parts. So I move on and we understand that at this moment, with very limited understanding on the seismic section, on the drill well, it is of the nature of prospective resource. As we climb up and interpret it, we can see a small hump here, and this small hump shows that there is a prospect which is there, close by a fault which runs like this. This fault divided into two parts, and the prospect is developed as has been seen here, where we have a low estimate, a best estimate and a high estimate for the closures from the top. If you see from a bird's eye view, we are trying to map the reservoir which is at this level on the seismic section, and we'll record more lines to understand the closure of the prospect. The prospect can be termed as a closure with a fault, and it's a fault closure prospect. So based on the closure, we can have an aerial estimate which is the low estimate, aerial estimate which is the most likely estimate, and an aerial extent which is the high estimate. These three values will go into the Monte Carlo simulation in order to have a stochastic understanding of the resource. We go forward and we can see there that we are still in the level of the prospective resource. Now how it will go into the contingent resource? We will put a well which has been drilled on the central part of the prospect. So the crestal part of the prospect we can see here is actually been harnessed by well number 1. But when we put the logs to it, we understand that we have drilled a well which has not gone into the TD. We have gone on drilling and we have found the lowest known gas. But we have not drilled a well which can talk about the gas-water contact. So we have to drill more wells in order to ascertain the gas-water contact. So what we do, we move on and we can understand that because of the lowest known gas, we have proved we have gone into the prospective resource. In order to convert resource into a reserve, there are 4 criteria which are there. That the resource should be discovered, the resource should be recoverable, it should be commercial, and the fourth point is also very important. Is there a market present? Is the FDP, the Field Development Plan, has been approved jointly by the operating committee, the management committee, and also the JV has enough money to develop it into a proper field development plan and implement the same. Till then, it is a contingent resource. If we don't fulfill any one of the criteria, the contingent resource will come back into the prospective resource. And this is true also in the upgradation stage, as we see through with an example. We have drilled one well, we have ascertained that the lowest known gas has been proved now. So we drill a well in the flank of the structure. We can see here, and we have done well logging. We understand that we have gone into the gas water contact. Now the initial estimate which you did on the aerial extent, which is the low estimate, the most likely estimate, and the high estimate, it is a time now to change the aerial extent based on the gas water contact. We cannot drill a well beyond this because it will go into the water regime. So it is a chance to redefine your map in order to make a real estimate of your resource. And this is called the appraisal drilling phase, and we will now put appraisal wells in order to move it into the reserve domain. If filled, we go back from the reserve into contingent resource. And if still it falls down, it can go back to the prospective resource also. So what we see with the white dot, we can see that there is an appraisal plan which is there, and each of the wells will have a well trajectory, and in the subsurface it will limit an hydrocarbon recovery which will be brought through the production wells. We can see this with this small circle. The yellow circle talks about the area which has been drained by the well which has been drilled there. The exploration well has been converted into an appraisal well, and many number of appraisal wells has been drilled, and you can see the whole area has been drained out. Appraisal moves into a development phase, and into the development phase more wells are drilled between two successful wells, and the development plan is fulfilled. And what we see that in this case the resource is moved to the reserve category. Once again I should highlight that every parameter, every technology has been fulfilled. Still, if you don't have enough money to develop the development plan which you have envisaged, has submitted to DGH, the reserve will come into the resource category. Thank you very much for the patient hearing. The third part of the resource reserve estimation. We have briefed you that how resource and reserve need to be classified, and we have given you an algorithm of preparing the resource and reserve in a stochastic manner. We'll go forward and see that how listing should be done to the resource what we calculate in the prospective domain, in the contingent domain, and how it is upgraded into the reserve. We understand that there are several methods of reserve estimation. One of them is volumetric method, the mathematical model, the comparable reservoirs, and also we do a performance analysis based on pressure data. But what we'll be talking about today is the volumetric stochastic method, which is applied mostly to exploration blocks when we calculate the reserve in a stochastic domain. Now under these two methodologies, deterministic method is a specialized case of the probabilistic method. That means there is one number for area, one number for porosity, one number for hydrocarbon saturation, formation volume factor, and recovery factor. Only one number is guesstimated out, which is the most likely number from the range of values what we will get from the probabilistic method. Whereas the probabilistic method, I have already told, is based on Monte Carlo simulation or very fast simulated annealing or neural network technique. The artificial intelligence comes into it, and today is the domain where we have to talk about mathematical simulation. So there are softwares like Crystal Ball and Rigs at the red, which are used normally for calculations and estimation of resource in a stochastic domain. Both are comparable because we have seen that the P90 is equal to 1P, P50 is equal to 2P, and P10 is equal to 3P. So there are methods where deterministic domain can be equated, not equal, can be equated to probabilistic domain. Another important factor which I have already mentioned in my previous lectures is the probability of success. Probability of success is calculated for each of these prospects. It is different for each of the prospects. The reservoir may have a probability of success, but the prospect will have a different probability of success. So when we move from a regime of play to lead to prospect and drillable prospect, the probability of success increases. The probability of success, as we see in the screen, consists of source, reservoir, migration, trap and seal. We assign a value to each one of them or a range of value in a probabilistic domain to each one of them and multiply this probability of successes to get the final probability of success for the prospect or the drillable prospect, and we utilize that to calculate the risk recovered resource. We can see here an example which is the technical criterions which are given on the right to show that how we should quantify it. It is true for source, it is true for reservoir, migration, trap and seal. So we can see here, based on the probability, we can qualify that whether source is present or not. Or in the play level, we can say the probability is low. The source may not have been understood well. Based on the understanding, based on the methods which are applied to understand source, based on the method of pyrolysis, based on the method of TOC content, based on the method of vitrinite reflectance, we will be able to quantify source and give a probability number or a range of probability number to the probability of success. So this is what is about risk method of probability calculation for the resource estimation. Many of the people do an estimation based on unrisk factor, where we have the resource and we don't consider the risk, but that's not a good way of doing things. We need to understand the risks, the uncertainty in terms of the prospect development, in terms of its size, in terms of its reservoir, pay thickness and other factors which we have talked about, and use that as one numerical value or a range of numerical value in case of Monte Carlo simulation for risk recovered resource. So in many cases P mean is calculated as 0.3 into P90, 0.4 into P50 and 0.3 into P10. This is how the risking is done by the companies who certify resource and reserve, like Gaffney Klein, Ryder Scott and many other companies will do risking and reserve estimation for organizations who will go for IPO or organizations.
Good morning. Where we are currently standing is the geothermal power plant. This is the first power plant in Gujarat. This that generates electricity from hot water. So to start with, let's talk to Dr. Anirbid Sircar about the history of this power plant. I am currently standing with Dr. Anirbid Sircar. So Dr. Anirbid Sircar, can you please explain us the history of this plant?
I'll answer to the question which has been asked by Abhishek. Now, I'm proud to be standing in Dholera, in the Swaminarayan temple, in order to explain the motivation behind creating this geothermal power generation plant. Now, we all know that geothermal energy is a nascent stage in India. Not much work has been done. So when I and my fellow colleagues were researching on geothermal energy, we first tried to understand in Gujarat which are the potential areas for geothermal energy. We identified 17 hotspots through the literature survey, and we did our own surveys in gravity, magnetic, seismic, electrical and electromagnetic. Based on that, subsurface sweet spots were identified, but we understood that the enthalpy of the water will be about 40 to 50 degrees Celsius when it comes to the surface. It can be used for various societal benefits, which many people in India are trying to do. But we ventured into electricity generation. What we did, we drilled 2 wells on the sweet spot, and we took that hot water into our plant by the pipes. And that was put into the first a heat pump where we try to enhance the temperature of the water. We have two loops here. One is the geo loop, which is connected with the wells. We also use fluids for heat exchange between the water and the fluid to enhance the temperature. The heat pump helped us to enhance the temperature to 80 degrees Celsius, which was used for space heating and cooling. The Swamijis here are very kind enough to give their Sabha Mandap, where we have demonstrated the cooling effect, and the AHUs were important for that. The heating side was utilized with the hot water of 80 degrees Celsius, which went into the ORC, and today we develop about 20 kilowatt of electricity from the plant, which is plowed back into the system. And we can say this is the first geothermal plant in Gujarat and probably a sustainable plant for the first time in India. Thank you very much.
Okay, Dr. Anirbid Sircar. So my next question to you is, how exactly was this plant built?
I'll try to answer this question that in the first part I explained the motivation behind this plant. Now every plant creation requires funding, requires support. We are very fortunate that Government of Gujarat has motivated us, helped us in development of this plant. They have funded this project, and you know this project funding is so important in establishment of the plant. Now this plant was developed with the idea that we will have sustainable power for the people here, and we thought not only power will be generated, which will be plowed back into the system, we'll try to do a seasonal test on the power generation, and we'll try to see that how the amount of electricity which is generated is sustainable and is useful and can be put into the grid. That's the next step into this process. We are also trying to understand that whether solar energy can be integrated with the geothermal energy in order to improve the power generation and the cooling system. We have a 32 TR cooling in the Sabha Mandap system, and we would like to put other societal benefits from the rejected water. We can see a balneology which is there nearby, which is used for people from the villages who want to get their skin disease cured. We have a honey processing system here where honey has been processed and used by the people from the villages, and we are trying to also develop other societal benefits, like we will be putting shortly a desalination plant here in order to have good drinking water for the people and the village of Dholera and other places of Gujarat.
Part of the plant is the well that we see right now. This well supplies the geothermal water that then gets converted into electricity. The temperature of this water is about 40 to 50 degrees Celsius. The next part of the power plant are these pipes. These pipes are the ones that conduct the geothermal water and take them to the main tank. That you see behind me, this tank supplies geothermal water through the black pipes into this particular device. This device is called plate type heat exchanger. These silver pipes that you see behind me, these supply fresh water to this same device. Now what happens after this is that the heat from the geothermal water is transmitted, is exchanged to the fresh water, and the geothermal water is then rejected and sent to domestic use. The device that you see in front of me is called a heat pump. This heat pump device has a very simple basic principle. The device has an exchange fluid called R134A. Now, as you might be remembering that in the previous setup there was some rejected water and there was some fresh water that was further heated. So this heat pump has two sides, a cool side and a hot side. The rejected water goes to the cool side. In the cool side, this water is further heated by the exchange liquid. After the cooling is done, The rejected water is then sent to the temple, okay, where it is used for practically a lot of things. The hot side contains the fresh water, the water that we actually require. This water is further heated up to 80 degrees Celsius by the exchange fluid and then sent to a device known as ORC.
Very good.
Hearing a lot of noise in the background. That's because electricity is finally being generated using this machine known as ORC. This ORC stands for Organic Rankine Cycle. This device has four major components: feed pump, evaporator, condenser and turbine. Turbine being the main one. So you might be remembering that the heat pump supplied 80 degrees Celsius of hot water to this very device. That water is now being regulated in the turbine. This is mechanical energy being converted into electrical energy. This electricity will then be computed in a separate device. This whole process is that the electricity generated is currently being displayed on this laptop after being computed.
We have done several exploration in various parts of Gujarat, and the next project of ORC is thought to be in Unai, near Unai Mata temple. And as I told you, Unai has the hottest subsurface and the surface temperature. CEGs have also demonstrated many other projects which are for direct applications, where people from geology, chemistry, mechanical engineer, electrical engineer work together so that they can work on several direct applications like food processing unit, like base metal extraction from geothermal water, and also nurture with helium extraction from geothermal water. It has also showcased that the water which is coming out from the subsurface has corroding materials like salts, and this need to be cured by using a desalination unit, and a unique desalination unit is also fabricated, which has been showcased in Dholera, and the same will be replicated in Unai. The DST Tech Center is a unique center which nurtures the ecosystem of innovation and also propagates an idea of creating demonstrative projects, prototypes, and transfer these ideas to small scale industries and also large scale industry. The center is sponsored by DST, and several people has been recruited from chemistry background and also from engineering background, who have a holistic approach towards this center. In this center, we have worked on various projects which are demonstrative in PDU and other universities, and we have also evaluated 25 prototypes till date. These prototypes has been nurtured to make it scaled up and can be used in the industry. We are trying to manage a correlation between the prototype and the upscale product, and in this line DST Tech has arranged ecosystem IP talks which has churned the idea of that demonstration is the need for the hour. So what we have done is that we made IP talks with NIPAM, and also we have arranged several workshops in energy, health and water, which is the theme of DST Tech. In the recent past, one of our faculties has worked on a project which is a capsule to be used for skin diseases, and that product was transferred to the industry, which is a MSME, and it has been transferred to the medical industry for the use of common people. We have signed several MOUs with the universities across Gujarat, because we want to create an umbrella under which this ecosystem prevails, is nurtured and spread out to the larger world. Thank you very much.